So as what I have mentioned last time in our previous meetings, statistics has two large areas or branches, namely descriptive statistics and inferential statistics po. Descriptive statistics, as the name suggests, aims to describe data, for example, by means of frequencies, ranks, percents, measures of central tendency, measures of variability, and measures of position, for example. But apart from that, we have also mentioned the second area or branch, which is inferential statistics, which aims now to form conclusions or generalizations based from our data. And so tonight, we will be discussing one of them. Okay. But before we discuss the following, so what I mean to say is the first one that we will be discussing is independent samples t-test. Okay. Ma'am, please read po.
An independent sample t-test is often used to analyze the results of the three different types of study design. Number one, determining if there are differences between two independent groups. Number two, determining if there are differences between interventions. And number three, determining if there are differences in change scores.
Okay, thank you po. For example, let's say in our company, no? Or let's say in our classes, there are two sections. We gave them a test. And suppose you would like to compare who performs better. Is it class A or class B? Or let's say in your large class, you noted that you are able to group them into two groups, say in terms of sex. And so, for example, you might ask yourself, who has better performance in my subject? Is it the males or is it the females? So, if you are interested in answering those types of questions, and if you satisfy the conditions on the use of parametric tests, then independent samples t-test may be used for that purpose. If you would like also to determine if there are differences between interventions, for example, if one group is your control group, the other group is your experimental group. So you noted their test results. So who performs better, the control group or the experimental groups? Since there are only two groups involved, then independent samples t-test can be used for such purpose, or if there are differences in change scores. And take note that independent samples t-test is a parametric test, which means to say whatever we can conclude from the sample can also be used to conclude to our population. Thus, since independent samples t-test is also powerful compared to its non-parametric counterpart, which is the Mann-Whitney U. In order to run an independent samples t-test, there are 6 assumptions that need to be considered. The first 3 assumptions relate to your choice of study design and the measurements you chose to make, while the second 3 assumptions relate to the characteristics of the data that you actually collected. Okay, with such, let's have assumption number 1. The first assumption is you have one dependent variable that is measured at the continuous level. Take note, you have an independent variable and you have a dependent variable. It is an important assumption that our dependent variable should be continuous. Meaning to say, remember we have 4 levels of measurement, namely nominal, ordinal, interval, and ratio. In this case, it is very important that our dependent variable is either interval or ratio data. If our dependent variable is nominal or ordinal, then we cannot use independent samples t-test. The second assumption is that you have one independent variable that consists of two categorical independent groups. That is, you have dichotomous variable. For example, if we talk about sex, then male, female, there are only two groups. If we talk about location, perhaps you could group them into rural and urban. So you see there are also two groups. Example independent variables that meet this criterion could include gender or sex. The two groups could be males or females. Employment status, for example, it could either be employed or unemployed. For the transport type, let's say two groups, those who ride the bus or those who ride cars. Or let's say trial, let's say the two groups. The first one is intervention and the other one is your control group, and many more. The third assumption is that you should have independence of observations, which means that there is no relationship between the observations in each group of the independent variable or between the groups themselves. When we speak about independent groups in an independent samples t-test, these are groups where there is no relationship between the participants in either of the groups. To make it simple, a participant, or let's say a respondent or participant of yours, does not influence the scores of other participants within the group or on the other group. Ma'am, please read the next assumption.
Assumption number 4, there should be no significant outliers in the two groups of your independent variable in terms of the dependent variable.
Okay, thank you. Due to the effect that outliers can have on your results, you have to choose whether to include these in your data when performing an independent samples t-test in SPSS. There are some instances, depending on the context, that the outliers are removed. So as for us to use independent samples t-test. When we say outliers, these are extreme scores. It's either extremely high or extremely low scores. Your dependent variable should be approximately normally distributed for each group of your independent variable. The independent samples t-test is considered robust to violations of normality. This means that some violations of this assumption can be tolerated and the test will still provide valid results. Therefore, you will often hear of this test only requiring approximately normal data. Furthermore, as sample size increases, the distribution can be very non-normal. And however, we have to thank what we call the central limit theorem, because the central limit theorem states that as you increase your sample size, then most likely you will be reaching the true mean of your distribution. Then the independent samples t-test can still provide valid results for such. That's why assumption number 5 can somehow be violated or can be tolerated, I mean. And the sixth one, you have homogeneity of variances. That is, the variance is equal in each group of your independent variable. The assumption of homogeneity of variances states that the population variance for each group of your independent variable is the same. If the sample size in each group is similar, the violation of this assumption is not often too serious. However, if the sample sizes are quite different, say one group has a lot of respondents, the other group has fewer, then the independent samples t-test is sensitive to the violation of this assumption. Do you have any questions so far, ma'am, or clarifications about this?
None so far po, Doc.
Okay, thank you. Now, let's talk about, let's have an example. Let's say studying the difference between two independent groups. If you measure a dependent variable, for example, ma'am, yung salary natin, and you could categorize your respondents into two independent groups, say sex, males and females, and wish to compare the dependent variable between these two groups, you can take the mean of the dependent variable in each group and use an independent samples t-test to compare them. Halimbawa, you learned that the mean salary of the males is, let's say, 30,000 pesos. You learn also about the mean salary of the females, which is 35,000 pesos. So you would like to compare who has a significantly higher salary. Is it the males or is it the females? Yun po yung example natin. So for the null hypothesis for an independent samples t-test, you could state it this way. Your HO is actually your null hypothesis. Let's say, you could say there is no significant difference in the state the dependent variable between group 1 and group 2. You could say also your alternative hypothesis or your HA, other books call it H1. There is a significant difference in the dependent variable between group 1 and group 2. You could see from here, no? This is the traditional way of stating our hypothesis. And the only difference is that your HO, there is no. And for your HA, there is a significant difference. Our HO sticks to the status quo. And our HA is claiming that we have to go away with the status quo. An independent samples t-test will calculate a significance level or say p-value, which is the probability of your sample group means being at least as different as you found in your study, given that the null hypothesis is indeed. And to make our life simpler, let us note of the following. In some books, majority of the books or references I saw use only less than. They don't use less than or equal to. Okay, but for now, if P is less than or equal to your alpha, and your alpha is usually 0.05. In our case, for our class, our alpha will be set as 0.05. If the computed P value is less than or equal to your alpha, then we have to reject the null hypothesis and we have to report and interpret our HA or H1. Take note, HA or H1 signifies alternative hypothesis. So we can utilize any of these two. However, if P is greater than alpha, do not reject HO. And since we do not reject HO or our null hypothesis, then we have to report and interpret the same null hypothesis. And whenever possible, it is recommended that the researcher also provides a higher interpretation of the hypothesis you reported. Note that you cannot accept the null hypothesis. Remember that it is not the sample means, but the population means that the hypothesis tests are actually referring to. Because remember as well, we are just using sample data in order to generalize to our population. Note, in SPSS, you cannot directly see the term p-value. However, it appears as sig, or in some instances, sig two-tailed. The results of independent samples t-test for our class will be reported this way. First, you will write there the italicized T. Then, inside the parentheses, we will place there the value of DF or the degrees of freedom equals blank, where this is now the t value, comma, p equals this. Note that the p value, which is your sig or sig2 tail, will be reported in 3 decimal places, whereas alpha will be reported in 2 decimal places. For our case, we will just use alpha equals 0.05. And for our class, we will be utilizing the following steps in conducting hypothesis testing. 1, we will state the problem. 2, we will state the HO and HA. State the significance level alpha, which is just 0.05 for our case. We will state the test statistic. Then we will also mention about the decision rule, which I discussed earlier. The 6th step will be computing for the test statistic, but don't worry, we will not do this manually. We will do this with the help of SPSS. Then for number 7, we will state the decision. And lastly, our conclusion. Note that if you will consult the internet or visit the internet, the steps that they are suggesting is different from mine. But for now, for our class, we will be utilizing these steps. Any questions so far, ma'am?
Wala naman po so far, Doc.
Okay, thank you po. So let us do now our class exercise using SPSS. All right, let's do this. Please open the file, ma'am. All right. Please open independent t-test versus Mann Whitney U statistics practice.sav. But for now, I will be running only the independent samples t-test copy. So you could see from here that for our variables, we have the following. We have sex, department, self-efficacy, business knowledge, monthly expenditures, and business assertiveness. Take note that sex and department are actually nominal variables here. And if you could see from here, it appears as 1, 2, 1, 2, 1, 2 for sex, for department 1, 2, 1, 2 also, and so on. You might be wondering, what is that 1, 2, 1, 2 for sex and department mean? So if we go back to the variable view, for you to know what they are, so you see for sex, go to values. Values is here. On the right side here, if you left click on it, you could see that I encoded there 1 equals male and 2 equals female. All right. That's why for the sex part earlier, 1 means male and 2 means female. So I'll close this. For the department part, so if you go to values and on the right side of it, you left click on it, 1 means finance. Meaning, if 1 is finance, the respondent comes from the finance department. And if you could see there 2, that means the respondent came from the management department. So I will not make changes on it, so click OK. And for the self-efficacy, these are all scales because self-efficacy, all of this are at least interval. So you might see here, so scale. Take note, you could see only here nominal, ordinal, or scale. If a variable, if you could see here that there's no, sir, where's interval, where's ratio? In SPSS, if your data is interval or ratio, then it appears as scale. And take note, it is us who actually encodes the data there. So sex is nominal. I'll click this one. Department is also nominal, but the rest are on scale. So take note, if your variables are in scale or are interval or ratio, then the values here are not needed to be supplied. And if we go back to data view, so you could see here. So you might be interested. Whoa, one is male and two is female, right? And for the department, one is finance and two is management. If you wanted to see the actual, you could see this one here, the value labels. If you click on it, you could see male, female, and so on. So finance, management, finance, and so on. Clicking on it again will give you the numbers actually. Okay. I hope you understand Puma. Okay po?
Yes
I
po,
hope so.
Doc.
Okay, thank you. So now, let's do the hypothesis testing. All right, let's do our independent sample t-test exercise. So for the directions, please refer to the independent t-test versus Mann Whitney U statistics practice file for the data. So given the situation below, identify the appropriate statistical tool and perform 8-step hypothesis testing. Okay, please read letter A, ma'am.
Mr. Chen would like to determine if male and female businessmen differ in their self-efficacy. He chose 20 people via random sampling. The highest score is 10, while the lowest score is 0. After gathering interval data, he tallied the results.
Okay. So one of the inferential research question that we could ask here is there a significant difference in the self-efficacy of male and female businessmen? If you wish, you could also ask, is there a significant difference in the self-efficacy of respondents when they are grouped according to sex? Take note that the way we state our problem could vary. And for the second step, state HO and HA. HO is null hypothesis, while HA is alternative hypothesis. If you use H1 in terms of instead of HA for alternative hypothesis, that is also considered correct. For my HO, there is no significant difference in the self-efficacy of male and female businessmen. For our HA, there is a significant difference in the self-efficacy of male and female businessmen. If you could see, the way we pattern our HO and HA is similar on how we stated our problem. The is there a became there is. And of course, from a question, our hypothesis now becomes a sentence that ends with a period. The HO, there is no. HA, there is a. For the significance level for our class, we will be using alpha equals 0.05 all throughout only. For the fourth, which is state the test statistic, so we will be using t-test for independent samples, or you could also say independent samples t-test. And our decision rule, which is the same all throughout for our class, if P is less than or equal to our alpha, then we have to reject HO and report the alternative hypothesis. However, if P is greater than alpha, then do not reject HO and we have to report our HO. Do you have any questions so far, ma'am, about the first 5 steps?
None so far po, Doc.
Okay, so if that's the case, I will now go to SPSS and do the computation. Before, sometimes doing statistics would take months, but with the power of some softwares like SPSS, we can do them in a few seconds or even a few minutes. So take note, in our data view, take note, we will be determining their self-efficacy, if there's a difference in their self-efficacy when they are grouped according to sex. Take note, independent samples t-test is a test of difference. So now, how to do this? To do independent samples t-test, we will go to analyze. And don't worry, you will be provided with a video later. After going to analyze, you go to compare means. And after you go to compare means, you will actually go to independent samples t-test. And if you are here, you click it and it will show you the this table. Take note, you could see earlier that there was something there because I did an initial practice earlier. That's why. Now, suppose it gives you something like this. Your goal is to remember your grouping variable is sex. It's your nominal variable. And the nominal variable should be the one that's going to your grouping variable. So click on sex and click the arrow leading towards the grouping variable. If you could see, after doing such, sex is now here, but there's a question mark. There are two question marks inside the parentheses. If that happens, then click define groups. And for group 1, type in 1. And for group 2, type in 2. You might be asking, sir, why? What's the purpose of that? Because if you could remember with our legend earlier, 1 represents males and 2 represents females. Group 1 is the group of the males, whereas 2 is the group of the females. If that's the case now, then click continue. Okay? Now, remember, our dependent variable earlier was self-efficacy, right? So click self-efficacy and click the R and place it in our test variable so that you won't get confused. The nominal variable goes to the grouping variable, whereas the variable that are in scale, meaning the ones that have this some sort of like ruler, goes to the test variable part. Can you follow, ma'am?
Yes, Doc.
And if you have done this step, now click OK. And it will show you this table. Okay. So what does this mean? If you could see, no, if you could see from here, this one, if we click on this one, let's see if this could be enlarged. I think it cannot be enlarged further. Now, if you could see for the self-efficacy here, N in N, there are male 12 and female 8. What does this mean? It means that in the data that you have, there are 12 males and there are 8 females. Take note, it's just small here. Why? In reality, there should be at least 30, or let's say sometimes 60, or even hundreds of them. However, for practice purposes, we only opted for small number of data because it's just for practice anyway. So, and the mean self-efficacy of the males has a score of 9.24, and the mean self-efficacy of females is 9.2325 something. And you could also see the standard deviations of their self-efficacy scores. Okay, in your opinion, ma'am, do you think the difference in the self-efficacies based on the mean, do you think is it large or not? Because if it is large, then most likely it's significant. If it is just small,
Mm,
maybe most likely not significant. What do you think, Paul?
the difference is just small, Doc.
So, in your opinion, is this significant or not?
Not po, Doc.
Okay. But if you could also see, there is another table here, which is the independent samples t-test. And in this case, I actually copied it and magnified it in this manner. So here are their means and standard deviations. I just copied the table and this one. You could see a lot of numbers there. And there are two rows for here, no? We have the equal variances assumed row and the equal variances not assumed row. Now, take note, we will only report three numbers here for our class. The first number that we will report is the T, the DF or the degrees of freedom, and the sig two-tailed only. That's why I highlighted them in red. And the rest of the numbers need not be reported. Now, you might be asking, sir, what will we report? Shall we report the equal variances assumed? Or shall we report the equal variances not assumed? Here's the thing. To do that, to decide which one to report, go to Levin's test. Take a look at the F and the sig. Here's the thing. Look at the sig of Levin's test, 0.367. And we have a rule here. That is, if the value of the sig of Levin's test is greater than 0.05, then we will report the T, DF, and sig two-tailed of the first row. However, if the sig of the Levin's test is less than 0.05, then it's better to report the T, DF, and sig two-tailed of the second row. Since you could see that the sig two-tailed, the sig of the Levin's test is 0.367, which is greater than 0.05, that is the reason why I highlighted these in red, that I will report the T, DF, and sig two-tailed of the equal variances assumed, or the first row here. Then, again, using the conventions we had earlier, so to report the results of t-test, of independent samples t-test, I have here an italicized T. Inside, we have here the DF, which is 18. Then close parenthesis equals, the value of T will be reported. But if you could see, it's 0.033. But for our class, we will round it off to 2 decimal places only. That's why 0.03, comma. And remember, as what I mentioned earlier, the sig two-tailed or is the p-value, no, for the t-test here. That's why hindi nyo po makikita directly yung p-value, but it's actually the sig two-tailed here. The sig two-tailed here is 0.974. That's why I had it in 3 decimal places. The rest could be in at most 2 decimal places na lang po. And if you could see, no, di ba yung p-value natin, which is 0.974, is greater than our alpha, which is 0.05. Di po ba? Do you agree, ma'am?
Yes, Doc.
Okay. And that's why, and remember, if we go back, what happens po if P is greater than alpha? Ano pong nakasabi dito if P is greater than alpha?
Reject the HO and
Saan po
report
yung,
HO po.
yung first po o yung ikalawa? Saan po yung i-report ninyo? Kasi P natin is greater. Ang greater than po, the greater than symbol, it's like facing left. The less than symbol, it's like facing right. Di ba? Ito po, yung ating greater than symbol.
Yes po, Doc.
And if you could see here, P is greater than alpha because 0.974 is greater than 0.05. So, therefore, we will what? It says here, do not reject.
Do not reject.
We will not reject HO and report HO. That's why we have this here. That's why for the conclusion part, what I did was go back to the first part, copy the HO. So I copy this. There is no significant differences in the self-efficacy of male and female businessmen. I copied it. Then I just write here thus because we're concluding. Thus, then I place there the null hypothesis. Thus, there is no significant difference in the self-efficacy of male and female businessmen. So that's it. However, we wish to have a higher interpretation or another interpretation. What does this mean? It means, or this implies, that businessmen have similar or comparable self efficacy regardless of their sex. Or you could also say that male and female businessmen have similar or comparable self efficacy. I hope you got it, Paul. Thank you.
Yes.
So, in this case, although in reality, their mean self-efficacy is really different. It differs actually. But since there is no significant difference, then actually we could say that their self-efficacy, the male, the self-efficacy of males and females are actually similar, statistically speaking, even though in reality they are different. So they have comparable self-efficacy. And that is an example of a on how we do independent sample hypothesis testing with independent samples t-test. And here the results is not significant. Now, how about let's have another example. How about if we have a result that is significant? So from here, ma'am, please read the second one, the problem there on top.
Mr. Chen would like to determine if there is a significant difference in the business knowledge of employees when they are grouped according to department. He chose 20 people via systematic sampling. The highest score is 5, while the lowest score is 1. After gathering interval data, he tallied the results and solved for relevant statistics.
Okay. Please read, ma'am, the 1 to 3.
State the problem. Is there a significant difference in the business knowledge of employees when they are grouped according to department? State HO and HA. HO, there is no significant difference in the business knowledge of employees when they are grouped according to department. HA, there is a significant difference in the business knowledge of employees when they are grouped according to department. State the significant level of I don't know how to
Alpha.
read this
Alpha.
doc.
That's alpha.
The alpha. Yeah, alpha. Alpha is equals to 0.05.
Okay, thank you, Paul. And for the test statistic part, it's t-test for independent samples. And the decision rule po will be the same all throughout. That is, if P is less than or equal to alpha, then reject HO and report the HA. And if P is greater than alpha, then do not reject HO and report HO. Take note that in some books, they just use the less than symbol and no more equal sign. So depending on your reference. So we have the first five, we have stated the first 5 parts. Now it's time to go to our hypothesis testing. So let's go here. So now, remember, there are only, take note that independent samples t-test can only be used if there are 2 groups only. Okay, it's capable of comparing or determining if there's a significant difference when you group them according to 2 independent groups. So for department, there are only 2 departments earlier, that's finance and management. So, and we will compare if there's a difference in their business knowledge. Take note that department here is nominal. It's also dichotomous because there are only two groups. And business knowledge here is state. So again, let's do independent samples t-test. We will go to analyze. After analyze, can you still remember what to do, ma'am? We will go to
The wait, compare means po.
okay. Then after compare means, what's next po?
Independent sample t-test.
Okay, good. We will go to independent samples t-test. And from here, we can now. So you see, the previous thing that we ran, it's still there. That's why it usually happens if we are using SPSS. So we don't want them for now. So let's place them back. Let's have department. Where will I place the department, ma'am? Will it be on the test variable or grouping variable?
Grouping variable po, Doc.
Okay. Then you see there are question marks. What do we do next?
Define groups po.
Exactly. Then group 1 will be 1 and group 2 will be 2. If you
Yes
could
po.
still
Yes
remember,
po.
1 is, if I'm correct, that's finance. And group 2 is that of the management na group. If that's the case, then we'll continue. And it's business knowledge, right? Where do we place business knowledge?
Test variables po, Doc.
Exactly. And if we have done this, what's next, ma'am? We will click.
Okay.
Okay. And here's the result. Okay. And I already copied it actually last time. Now let's have the following. So ito po, yung kanilang means and standard deviation. You could see that there are 10 from finance, 10 from management, and here are their means. So the mean business knowledge is 4.8670 with a standard deviation of 0.14967 for the finance group. For the management group, it's 3.9570 with a standard deviation of 0.19311. Now, in your opinion po, take a look at their means. Do you think significant po yung difference sa means nila or hindi?
Doc, I'm sorry, parang nag-choppy po. Sandali.
Okay.
Ano po ulit, Doc?
Okay. In your opinion po, tingnan niyo po yung means nila. Do you think the difference is significant or not?
Yes po. It's a little bit big po yung difference
And
compared sa
it's like,
kanina po.
no? So it's like finance is a bit larger in terms of mean. But again, we have to
Yes
check
po.
the independent samples test. And if you could see, shall we report the first row? Shall we report the equal variances assumed or the equal variances not assumed? We will because if you could take a look at the Levine's test.
That po.
Okay, this one is larger, no? The sig of the Levine's test is larger than 0.05. Therefore, we will report the T, the DF, and the sig two-tailed of the equal variance is assumed like this. And again, take note, in reality, it should not be red. I just place it in red for emphasis. And again, in reporting, so you write there T, then open parenthesis, write there the DF or the degrees of freedom inside equals, then the T value. However, it's just rounded to 2 decimal places, 11.78, comma P. Ano po yung P dito, ma'am? Saan po siya? T, DF, or si 2 tilde po ba yan? Yung P natin, P value. The P
DF po,
value
Doc.
is P.
DF.
Notice yung po 0.000 siya, no? which is this. Sig two-tailed po yan, ma'am.
Yes.
Okay? So yung sig two-tailed, that's why hindi nyo po makikita directly yung p-value. Sig two-tailed po yan actually. That's why for this case, 0.000. Di ba? Ano nga yung alpha natin kanina, ma'am? Yung alpha natin kanina, it's 0.05, right?
Po. Yes po. It's
Now,
equals to 0.05.
is 0.000 less than or equal to 0.05?
Less than po, Doc.
Less than. That's why, if P is less than alpha, that's why nilagay ko po yan dito. Now, if dahil less than po siya, balikan po natin yung ating decision rule. Let's go back to it. What should we do because our P is less than alpha? Take a look po. Dahil P is less than alpha, which one are we going to do based on our decision rule?
Doc, parang nawala ka po, Doc.
Okay, sorry. So take a look, ma'am, at our decision rule. What should we do po? Since P is less than alpha. Are we going to reject HO or do not reject HO? We will. Because P is less than alpha, then we should reject HO and report HA. That's why I copied the alternative hypothesis or the HA earlier, and I wrote here, thus, comma, there is a significant difference in the business knowledge of employees when they are grouped according to department. And take note, if there is a significant difference, I will actually require you to go back to the means. You could see here that finance as a higher mean than the management group. That's why it has certain implications. It could be seen that the mean business knowledge of those in the finance department is higher than those in the management, than those of the management department employees. Then it could be said that employees in the finance department have higher or better business knowledge than those who are from the management department. I hope you learned something important today. So that ends the discussion on independent samples t-test.